All right, here we are, video 2. We are now going to use our derivative formulas for the inverse trig functions. Remember, the whole purpose of sine inverse, tangent inverse, and secant inverse is to find angles. We're given the ratio, we're going to find angles, right? But that's how they were created. But then after a while, it really doesn't matter what the number is that you're plugging in and what the number is that you're plugging out. You're still going to find the derivative the way you normally would. And so when I look at example 2 here, um, when I look at example 2, it says we're given the graph of h of x. The graph of h of x is given below. If f of x is the quotient of sine inverse x divided by hx, then let's find f prime at square root of 3 divided by 2. Okay, so we're going to find the derivative of f. I have a top numerator, a bottom denominator function. So we're going to find f prime. F prime of x is the derivative of the top. Well, the derivative of sine inverse, we said the sine inverse of x is the derivative of x, which is just 1, over the square root of 1 minus x squared. Okay, so that's 1 over square root of 1 minus x squared. That's the derivative of the top, times the bottom, minus the derivative of the bottom, which would be h prime. By the way, I'm setting up a quotient rule because we're dividing, right? Times the top, which is sine inverse of x, all divided by h of x squared. So this is what we're supposed to figure out. Well, this is the derivative function, but they want us to figure out a derivative value at the point square root of 3 over 2. So then here I'm going to say f prime at square root of 3 over 2 is 1 over the square root of 1 minus, I'm running out of space here and I'm imagining you are too. I'm going to zoom in. 1 over the square root of 1 minus square root of 3 over 2 squared times h of square root of 3. Let me keep it the same color. H at square root of 3 over 2 minus h prime at square root of 3 over 2 times the sine inverse of square root of 3 over 2. All divided by whatever h of square root of 3 over 2 is, quantity squared. All right, we have a lot going on here. So part of these we're going to have to just evaluate, like calculate, right? And then some of these we're going to have to use the graph in order to figure it out. All right, so this equals, let's see, 1 over the square root of 1 minus the square root of 3 over 2 squared. So really that's 1 over the square root of 1 minus 3/4, right? If you square square root of 3, you get 3. If you square 2, you get 4. But 1 minus the square root of 1 minus 3/4 is really just the square root of 1/4. So all of that just became 1/4. All of this inside became 1/4. Oh, but the square root of 1/4 is the square root of 1 over the square root of 4. So all of this becomes 1/2. And then 1 divided by 1/2, all of that just becomes 2. So I went from this original fraction to just 2. And now I'm going to have to look at the graph. I have to look at the graph because the next part is find h of square root of 3 over 2. So I go to my graph. H of square root of 3 over 2. Well, wait, how much is square root of 3 over 2? Square root of 3 divided by 2. That's about 0.866. How do I know that? I don't know. I just memorized that square root of 3 is about 1.7 divided by 2. So it's somewhere around there, 1.73, I think. So it's one of those decimals that if you remember it, it makes life a lot easier. So when x equals 0.866, so somewhere here is square root of 3 over 2. My y is 3. Oh, well, that's easy. So then it's times 3 minus the derivative at square root of 3 over 2. Well, the derivative at that point, this graph is flat. So the derivative is 0. And I guess it really doesn't matter what sine inverse of that is because it's going to multiply out to 0 divided by, what did we say h of square root of 3 over 2 was? I believe we said it was 3, but we're going to need to square it. Okay, so then now we know this is going to go away because 0 times anything is 0. So I'm left with 6 over 9, and 6 over 9 is 2/3. Here is the derivative value that I was looking for. We're starting to blend different rules, different shortcut rules. In this function example, we had a quotient. We were dividing, so I had to do the quotient setup in order to find my derivatives. But as I was finding the derivative at the top, I need to know the derivative for sine inverse, which is what this formula is. And then I also need to know that the derivative of a graph is really just asking me for the slope. And so this part was asking me for the slope at square root of 3 over 2. And then I guess one of the other things we needed to know is that square root of 3 over 2 is about 0.866, just like square root of 2 over 2 is about 0.707. And I guess the other fraction that we know is 1/2, but you know that that's 0.5. So if you remember those decimals, it can help you save some time and move a little bit faster. But again, we're using all the rules, including the new inverse trig function derivative rules.